Welcome, finite mathematicians, to a new chapter and a new lesson, 3.1, graphing inequalities. Again, this is mainly review type stuff, so let's get right on into it. Inequalities, just remember that those are things like less than, greater than, less than or equal to, greater than or equal to. New terminology, so to speak, we call these non-strict, okay, the equal tos. And ones that are not equal to, we call those strict inequalities. For example, I can spend up to $25. That would be our money. Okay, up to has to be less than 25. Okay, we cannot spend $25 included up to $25. You can work no more than 35 hours in a week. So our hours have to be less than 35. Okay, it can be hard to designate strict or non-strict, especially in this case. For the most part, I will try and be very specific as to I can spend up to, but maybe not including, and things like that. Okay. You can work no more than 35 hours in a week. I have to buy at least 2 dozen. At least is one case where it is pretty well known that you can have, so 2 dozen equal to in this case. So at least 2 dozen cupcakes would cut it there. Anyway, review graphing these. So that's just writing inequalities. Reviewing, graphing them, basically you need to decide a few things. First, you graph like an old school graph, and then you need to decide on a line type and shading. Okay, line types, if it is greater than or equal to and less than or equal to, you're going to use a solid line. Versus if it is greater than or less than, you're going to use a dotted line. Okay. As for shading, I'm going to go over the test point method, how to solve that. Our example here, you're going to start it very much as though it was equal to x plus 1. Graphing, hopefully by now, is not a major issue. You can use your graphing calculator. So we start at the y-intercept of 1. You go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, once you have some points down, then you can decide what type of line to use. Myself, we are going to use a solid line due to the fact this is equal to, so we can use a solid line and connect those points there. Yes, I have a little cheat tool here to help me connect those points. That looks pretty good. Alright, so we decided line type, and now we just need to decide on the shading, because really there's an infinite number of solutions to this. We just need to decide where they are. So the test point method asks that you pick any point not on the graph. So pick a point not on the graph. Pick a point, any point, not on that line. Okay, so not on the line specifically. Most likely the easiest point to pick would be 0, 0. Okay, 0, 0. What you do with that test point is you substitute that in for x and y into your original equation. So y is 0, we have is greater than or equal to 2 times 0 plus 1. Okay, 0 for x, 0 for y. Alright, 0, 0 is nice because most of the time things are going to cancel out. So 0 is greater than or equal to 1. Is that true? No. 0 is not greater than or equal to 1. So here's the big takeaway. This is the point that is false. Okay? Well, that point being false means that everything else over here is false. On the flip side, all these answers must be true. So if you shade those ones in, you would get the right answer. Okay, there are ways to use your calculator and stuff, but really the test point method is most accurate. Now, just to show you, if perhaps, say you picked a point in the true side. So let's say we picked the point, let's pick an easy one here. Okay, let's say we picked 0, and that is 1, 2, 3, 4, 5, 6, 7, 8. If you tested that point out, you would have, so 0, 8, sorry, x is 0, y is 8, you'd have 8 is greater than or equal to 2 times 0 plus 1. Well, in this case, 8 surely is greater than 1, which means that is there. It's a good point. You want all those things on that side. Okay? So pick a test point. That's the best way to go about it. Also, you can do inequalities with vertical, horizontal lines. X equals Van Halen. Yeah, that's right. So x is a vertical line at 4, boop, 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 and solid due to equal to. So we're just gonna connect that guy there. Boom, boom. And this one here, one way to think of it is think of what x values are greater than 4. You can even pick a test point, okay? If you pick the point 0, 0, and you ask yourself, is 0 greater than or equal to 4? No, that's false. So you would want everything on the other side. Also, just think, what x's are greater than 4? The x's that are greater than 4 are on this side here. Wonderful, yes. There you go. Okay, easy peasy. Now, we graph systems of inequalities. This is just as fun as graphing 2 at once. Okay? So, just graph them one at a time. Alright, you might need to put them into standard form. No big deal. These are just all skills that you should have in your pocket already. So, if we have 2y is less than or equal to negative 3x plus 6, all I did was subtract the 3x over, divide by 2, divide by 2, divide by 2. Means that y is less than or equal to negative 3 halves x plus 3. Okay, just going to graph them one at a time. So, up 3, boop, boop, boop. Down 3 over 2, boop, 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 boop. Solid line. Doing a lot of examples with solid lines. Hopefully some others appear here. Okay. Shading. Let's pick at test point 0, 0. That's my test point. TP, not toilet paper. 0 less than or equal to 3 halves x, which would be 0 plus 3. Is 0 less than or equal to 3? Sure is. Okay, so we're going to shade everything below this line. Yeah, I went a little above there. Let's just take care of that. Okay, so that's that one there. Let's take a look at the other graph. Graphing the second one. So, we'll subtract the 3x over. We have the 2y is greater than or equal to negative 3x minus 6. Divide by 2, divide by 2, divide by 2. Y is greater than or equal to negative 3 halves x minus 3. Let's go down. 1, 2, 3. Our slope is negative 3 halves, so 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Connect them with a solid line. Okay, that's looking pretty good. And in our case here, we're going to pick the test point 0, 0. So let's try it out again. Is 0 greater than or equal to 0 minus 3? Is 0 greater than or equal to negative 3? Yes, it is. Here's 0, 0. So for this graph, we want to shade everywhere above it. Okay, and now with systems of equations, your true solutions lie within the bounds. Okay, so where blue meets red in our case, it's everything in between. Feel free to use colored pencils. Just be careful if you happen to graph something wrong, then most likely you're going to have some interesting erasing and stuff to do. If you go ahead and erase everything else, that would be ideal, and just show the true solutions, that would be great. Okay, if you want to pause right now and try to graph this next system, you certainly can. Otherwise, I will go through it as well. Okay, so remember, graph it one at a time. Hey, let's notice these two are the same. Okay, so really, if we just start out graphing the same line as before, you'll be in good shape. Actually, no, they're not the same. Just kidding. 2x, 3y. So let's graph it. Okay, 3y is less than or equal to negative 2x plus 6. If we divide by 3, we have y less than or equal to negative 2/3 x plus 2. Up 2, down 2 over 3. Solid line again. And remember, pick a test point not on the graph. So fortunately, again, 0, 0 works out. 0 is less than or equal to 0 plus 2. Is 0 less than or equal to 2? It sure is. So we'll shade everything below. And we'll graph the second line, moving x over. You can also, hey, we could use the test point method, but we'll just do negative y is greater than or equal to negative x plus 2. You can divide by negative 1, divide by negative 1, divide by negative 1. That makes y greater than, or less than, sorry, equal to x minus 2. Big takeaway here, if you divide by a negative, you got to change the sign. So remember all that stuff from way before. Divide by negative, change the sign. Not subtracting, just dividing or multiplying by negative. So we're going to go down 2, up 1 over 1. Okay, solid line again. Just the way I was feeling, I guess, when I made these were the examples I found. All solid lines. Okay. Test point for this one, again, 0, 0 does not go through. It's the easiest one to test out. Is 0 less than or equal to negative 2? In this case here, it is false. 0 is not less than negative 2. So here is our test point. Again, our line is the blue one here. 0, 0 is false. Okay, it's on this side of the line, which means I want to shade everything on the opposite side of 0, 0. Okay, combining all that just leaves this little triangle here as your solutions. So red, in this case, are where the real solutions lie. Okay, it can be tricky with this test point stuff, so try these problems and you should again be doing your homework and trying them out. Okay, and just remember it was all down here. Okay, just the last thing you may have happen is, let's say you graph two lines and they are parallel lines. Okay, so let's say you graph them, and I'm just graphing any old lines here. Okay, so we graph one, And let's say we graph another one. And for example, let's say that you end up shading everywhere above this one, and you end up shading everywhere below this one, and nothing intersects. That just means there are no solutions. Okay? There are no solutions to this particular system. It would, if you remember, then be an inconsistent system. Okay, that's the main takeaway: graphing, shading, line type. Just remember, I know there weren't any examples, so greater than, equal to, use a dotted line. Okay, practice problems. Please feel that you should practice. Again, sorry. Should practice. Answers will be online. Thanks for watching, guys. Have a nice day.